This is section 8.5, and we are going to be talking about the binomial theorem today. It actually has to do a lot with foiling, and instead of you constantly foiling things out, this might have come a little handy on mathematical induction, especially when you get up to those fourth powers. But instead of you foiling things out, we're going to show you how to do something called Pascal's triangle and the binomial theorem in order for you to foil a lot quicker. So we usually start out talking just about a couple of easy foils. X plus y to the 0, anything to the 0 power is a 1. And I'm going to kind of space it out there. You'll see why in a minute. The numbers are going to kind of come together and create something for us. X plus y to the first, it just means x plus y. So there's one x and one y. X plus y squared, you would write them twice and then foil them out. So you'd have an x plus y and an x plus y, and then you would foil. So you would end up with an x squared, you'd end up with two xy's, and you'd end up with a y squared. When you do this to the third power, I'm just going to write it down here, x plus y, x plus y, x plus y. There are three of them. Now we already did x plus y squared. We already did that combination. That's right there. So I'm going to take that out and put that stuff in its place. So we got an x squared, two xy's, and a y squared. Now we need to foil it with an x plus y. So painstakingly, you kind of keep track of, draw those lines that you use for FOIL and keep track of who's getting multiplied. So I have an x cubed, then I have an x squared y, then I have a 2x squared y, then I have a 2xy squared, and then an xy squared, and then a y cubed. So combining these like terms, I end up with an x cubed, 3x squared y, 3xy squared, and 1y cubed. And the reason I wrote them in this way is just to show you the numbers. I always lead off with a 1. I always end with a 1. And in the middle, the way that you find those numbers is by adding the 2 above it. So if I want the middle term here, I add these 2 above it. 1 plus 1 is 2. If I want this term, I add 1 plus 2 and get 3. And this is called Pascal's triangle. You start off with a 1, and then you add these 2 to get the next term. You add these 2 to get the next term, and so on. And you can continue this out for quite a ways. So if we were going to multiply something out to the fourth power, these would be the coefficients in that row. So this is the third power row. We just did that, a 1, a 3, a 3, and a 1. This would be the fourth power row. Could continue and do a fifth power. These would be the coefficients of each of the terms if I foiled them out. And we're going to use this trick in order to make foiling a lot simpler for us. Something that goes along with binomial theorem is combinations, if you remember that from last year. So I'm just going to show you again where that is in your calculator. If you hit the math menu and then go over to probability, it's listed right there. The key to these is you need to first hit the 8, then go get that button, and then hit the 2. And what it's telling you actually is it's showing you where in the triangle that value is located. And so this was 28. So we're going to expand just a few more. We're going to multiply out a few more. But instead of writing them 3 times, or in this case writing them 4 times and foiling that out, we're going to use the cheat of Pythagorean's theorem. And I'm going to show you a couple of other tricks that make it so you don't need to foil anymore. So I'm just going to repeat Pascal's triangle over here. Actually, I want it on the screen, so let's do this right. So we'll start there with a 1, and then 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1. And that's as far as I need to go because we're only doing out to a fourth power. So the first one is x minus 1 to the third. So I'm going to take my third row, and I'm going to write the coefficients there, spacing them out a little bit because I'm going to have to put x's in there and stuff, so I'm just making a little room. Then you take the thing that came first in the parentheses, whatever that is. Here it's an x, here it's an x, here it happens to be a 2x. And you start at its highest power. So the very first thing, if I were to FOIL all this stuff out, I would end up with an x cubed for the very first thing. And then as I move along, I'll end up decreasing 1 in power each time until I don't have any. Taking the second thing in parentheses, the negative 2, the negative 1, the positive 2, or the negative 3, I'm going to come back but going the other way. So I'm going to go negative 1 to the third, negative 1 squared, negative 1 to the first, and negative 1 to the 0. And every time my exponents should equal the power that I have. So I have a third power, so that's a 3, that's 3, that's 3, this is 3. They should always equal the power. Now I'm just going to simplify a little bit. Negative 1 to the 0, that's just a 1, so that's gone. I don't need that guy, so I just have an x cubed. Negative 1 to the first power is a negative 1. So negative 1 times 3 is negative 3x squared. Negative 1 to the second power, that turns it even. So this will be positive 1. 1 times 3 is 3x to the first. X to the 0 is a 1. I don't need that. So I got negative 1 to the third, and that just makes it a negative. So without foiling, I am able to figure out what that answer would be if I expanded. Let's do the next one. Also a third power. So I'm going to use the same row, 1, 3, 3, 1. Taking my x, I'm going to go x cubed, x squared, x to the first, x to the 0. Taking my 2, coming back the other way. So 2 to the third, 2 squared, 2 to the first, 2 to the 0. And just simplifying, 2 to the 0 is 1, so I've got an x cubed. 2 to the first is 2. 2 times 3 is 6x squared. 2 squared is 4. 4 times 3 is 12x. 2 to the third is 8, and 8 times 1 is just 8. Last one, maybe pause the video, see if you can set it up before you reveal the answer. Using the fourth row of Pythagorean's theorem, these are my coefficients now, so you need a little bit more space. 2x to the fourth to the third squared to the first, and then none. Coming back the other way, I got a negative 3 to the fourth, negative 3 cubed, negative 3 squared, negative 3 to the first, and then to the 0. When you do this first term, we got 2x to the fourth, you need to make sure that it is 2 to the fourth and x to the fourth. That guy is gone. So 2 to the fourth is 16, x to the fourth. They both get the fourth power. It's kind of like writing 2x, 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 2x 4 times, and then doing that math. So I end up with 16x to the fourth. Next I have a negative 3 and a 4 for negative 12. Oops, sorry, I forgot the 2. So negative 3, I got a 2 in here and a 4. So I'm just going to kind of do a mini line here. I got a 4. This is going to be 8x cubed with a negative 3. So negative 3 times the 8 times the 4. So negative 96x cubed. Next one, I've got negative 3 squared, which is 9. I've got a 2 squared, which is 4, and a 6. Gives me a total of 216x squared. Here I have negative 3 to the third, which is negative 27, times 2 times 4. Last one, I have negative 3 to the fourth, times, oh, sorry, this is a 0. I thought that was a 6. 2 to the 0 and x to the 0 are gone. So I just have a 3 to the fourth, which is 81. So just double checking, my power should go down each time. So 4, 3, 2, 1, gone. And then all my coefficients. We don't want to keep doing that forever, though. I mean, if I want to find the sixth term of something to the eighth power, I do not want to have to write all that stuff out and then count down and figure out which one was my sixth term. We kind of want to be able to jump there. And so the binomial theorem talks about the expansion. So if you were going to expand anything to a power, so x plus y to a power, let's say 2x minus 3 to the 100th. What happens each time is you start with your first thing raised to the power, which we did, and then you decrease by 1 the whole way along. So first x to the n, and then x to the n minus 1, and then x to the n minus 2, and then minus 3, and then all the way down until you hit the other end where there aren't any. Here's x to the first, and then this would be x to the 0. And then going back the other way, you do the same thing. You'd have y to the n, and then y to the n minus 1, 1 less. And then you keep going all the way down until you end up with y to the first, and then no y's. So it's the same pattern we were doing, just in letters, in notation, not with numbers. The main part you need to focus on is this middle right here. This is more or less our formula, the thing you'd want to focus on. And it tells you how to find this term. So if you want the 8th term or you want the 5th term in the middle, it tells you how to find it. So first we've got this NCR thing, which is okay. We know how to enter that in our calculator. Then we've got this x, n minus r, and then y to the r. Okay. So where all this stuff comes from is, sorry, I keep reading here. The coefficient of any particular term is this guy. So it's kind of telling you where they're going to come out of Pascal's triangle. And then when we're looking for a term, we're going to follow this guy right here. We're going to come up with our coefficient. This is like our Pascal's, but without having to make the whole triangle. And then these two are going to give us our other terms, kind of like our 2x and then our extra thing. So let's try it with finding the third term of this guy, which we already know because we did it right up here. So we know this is the first term, the second term, the third term. So that's what we're looking for. We're just going to do it using the formula. So the third term of Pascal's triangle. Okay, so I start with my formula, NCR. So the n is the power. Sorry, I kind of wrote all in there. This is the power that you're raising it to. And then I have x to the n minus r and y to the r. And r is one less than what you're looking for. So if we're looking for the third term, we're actually going to do a 2 right there. And it has to do with Pascal's triangle starting off with a 1 right there. That's actually called row 0. And this is row 1, and this is row 2 and row 3. So to kind of compensate for that, we subtract 1 from what we want. So third term says I'm going to do 4, C, 4 goes for the power, C, 1 less, 2. Now I take the first thing that came in parentheses, 2x, and I raise it to the n minus r, 4 minus 2. I take the second thing in parentheses, negative 3, and I raise it to just the r, so 2. So 4c2, doing that in my calculator, I get 6 times, and 4 minus 2 is just 2. So I've got a 2 squared, I've got an x squared, and I've got negative 3 squared, which is 9. So putting the numbers together, I've got 6 times 4 times 9, which gives me 216 x squared, which is exactly what we already had, just kind of using the formula in order to find it. So I don't need to do out all of the terms in order to find just one of them. I can use this formula right here to figure it out. So let's do the next one. Sixth term of a plus 2b to the 8th. So I've got an 8c, 1 less, 5, a to the 8 minus 5, and 2b to the 5th. Just a reminder, these two powers have to add up to that guy right there. So if I've got a 3 here, I've got to make sure I have a 5 matching to get me to the 8. So just simplifying, I've got an 8c, 5, which is 56. I've got an a to the 3rd. I've got a 2 to the 5th and a b to the 5th. So I can put the two numbers together. 56 times 2 to the 5th is 1,792. A to the 3rd, b to the 5th. So that little formula just allowed me to kind of jump in, find the 6th term without having to do out all 8 terms and then counting up to the 6th. Biggest part about this is kids will forget to do 1 less than what you actually want. You'll get the power in the right spot because that's the biggest number, so that has to go there. The 8 goes there. But then they'll forget that that has to be 1 less than what you're looking for.